Hi there. So this lesson is a pretty quick one, which is kind of nice, but it's all about solving quadratic systems of equations. Now, the good thing is that we've already solved systems, and we're going to solve these systems pretty similarly. But the main concept or main idea is this. We've been talking about conic sections, parabolas, ellipses, circles, hyperbolas. And now it's what happens if these things intersect? How many solutions can we get? I have a couple examples here, and you could write. I'm only going to do one example when I actually do the notes. Feel free to write it or just kind of watch and then practice the problems on your own. That's up to you. But think about if I were to graph this system right here, part of this chapter I've said I want you to be able to look at an equation and know what the equation is going to form, like what graph it's going to form. For instance, if I look at this system, this here would be a circle, and this here would be a parabola. And then think about how many times a parabola can intersect a circle. If you have a circle and then you have a parabola, in these problems today, we could end up getting 1, 2, 3, 4 solutions to our systems. It's kind of the big idea. You don't have to have 4 solutions. You could have a circle and then a parabola that does something like this, where then you only have 2 solutions. But the idea is we are not going to be graphing these things, but solving through substitution or solving through elimination. But this is, when we find the solutions, what we're actually finding. And if I come over here, think about what these two things form. And again, this is a big thing that I want you guys to be able to do. This first one would be a hyperbola, because both things are squared being subtracted. This one is an ellipse, because both are squared being added. But this is the one a lot of students struggle with. Look at the difference between these two. This is a circle because the coefficients are the same. This one's an ellipse because the coefficients are different. So that's how you can tell the difference between a circle and an ellipse. Well, think about if you have a hyperbola, like this, and then an ellipse, we could still have 4 solutions. So the goal today is to find those solutions. It looks a lot more complicated than the process actually is, which is good. So here's the one example, and then you'll have a few problems to practice for your work. So let's do this system. X squared plus y squared equals 25, so a circle. And 3x squared minus 2y squared equals 10, hyperbola. Now what you're not allowed to do is change these equations and make square root all these terms. You can't do that. So in this quadratic, we are going to use elimination. Just like if they were not squared. If this is negative 2y squared, I want this to be 2y squared. So I'm going to multiply the whole top equation by 2. And then when I add these equations together, the y squareds cancel. So you get 5x squared equals 60. I can't square root yet. I do have to divide by 5 first. So x squared equals 12. And then remember, when you square root both sides, this is kind of where a lot of students struggle. It's kind of at the end here. You have to remember plus or minus, and I want you to simplify any radicals that we end up with. So x equals plus or minus, and then the square root of 12 is 2 radical 3. You could do your factor tree if you want, look for pairs, that whole process, or find perfect squares, but regardless, you have to be able to simplify. Now I have to find the y-coordinate. This means that these things are going to cross when x is 2 radical 3 and negative 2 radical 3. Now I got to find the corresponding y values. So I'm going to plug these back in for x, right here. It doesn't matter if you plug in positive or negative 2 radical 3, because when you square it, it's going to become 12 anyway. And in fact, someone the other day said, well, if we knew x squared was 12 from this line, can we just put 12 where x squared is here? And yeah, I didn't think of it that way, but absolutely. X squared is 12, so you can replace that x squared with 12. So that's kind of nice. But let's say you didn't see that. I think this is important to talk about. Let's say I did put 2 radical 3 and then squared it. Remember how to square radicals? You square the 2, so you get 4, and square the radical 3, which is 3. This is basically 4 times 3. And so you get 12 that way as well. So then we subtract 12, and then square root. Plus or minus, have to remember plus or minus. 13 doesn't simplify, so we just leave it. The way we write our ordered pairs for our answers, well, we would just put plus or minus 2 radical 3, comma, plus or minus square root of 13. When you write an ordered pair this way, what this means is the positive 2 radical 3 corresponds to both the plus and minus radical 13. So you are getting 4 solutions here. You have the positive x term going with positive and negative, and then the negative x term going with the positive and the negative. So there are 4 solutions where these cross. So if everything is quadratic, I would use elimination. I'm not going to work through this one, but say you had an equation that looks something like this. You have a circle and then you have a line. I would use substitution in this case because you can't just square both sides of this equation to make it x squared, y squared, and 16. It's not allowed. So I would probably add y over and then plug that in for the x here and use substitution that way. So I don't know if that shows up on some of your practice problems, but that is a possibility. So now you'll have a few problems to work through, and let me know if you have any questions.